Right, this is assignment number 8 of chapter 1. First numerical. A 40-gram mixture of calcium carbonate and magnesium carbonate left 20.64 grams of solid residue on strong heating. Calculate the percentage magnesium carbonate in the mixture. See, I'm writing two equations. Calcium carbonate gives calcium oxide, which is a solid, and carbon dioxide, which is a gas. Second, magnesium carbonate gives magnesium oxide, which again is solid, and carbon dioxide, is a gas. Now, in this case, we started with 40 grams mixture of these two. 40 grams. And after the reaction, 20.64 grams of solid residue was left. So mixture of these two solids left 20.64. Molecular weights are given. We have to calculate percentage of magnesium carbonate in the mixture. Let us say this is X grams. It means this will be 40 minus X grams. Molecular weights are given. This is 100. This is 56. This is 84. And this molecular weight is 40. Now, according to the equation, calcium oxide formed 100 grams will give 56 grams. 40 minus X will give how much? So this will be 56 divided by 100 into 40 minus X. So many grams will be formed. Second equation, 84 grams gives 40 grams of solid, that is magnesium oxide. X will give how much? So magnesium oxide formed will be 40 divided by 84 into X grams. Now, if we add these two solids, total weight will be equal to 20.64 grams. So now I'm equating. So 50 divided by 100 into 40 minus X plus 40X divided by 84 is equal to 20.64. Now from this, we'll calculate the value of X. X will come out to 21 grams. It means out of 40 grams of the mixture, magnesium carbonate was 21 grams. From that, we can calculate percentage. Magnesium carbonate will be equal to 21 divided by total 40 into 100. This is the percentage of magnesium carbonate. Second equation, the second numerical. Let me first write equations. 2KClO3 gives 2KCl plus 3O2. This is equation 1. Second, 4KClO3 gives 3KClO4 plus KCl. This is equation 1. 39.2 grams KClO3 was heated under such conditions that it simultaneously decomposed according to following two equations. These are two equations. Calculate the amount of KClO4 produced if 6.72 liters of oxygen was collected. Now, see, oxygen is produced in reaction 1 only, not in reaction 2. Now, number of moles of KClO3 started with, this was 39.2 grams divided by molecular weight 122.5. This will come out to 0.12 mole. Now, oxygen, number of moles of oxygen formed. This will be, we are given 6.72 liters. 6.72 liters divided by 22.4. This will come out to 0.03 mole. Now look at the equation. to produce 3 moles of oxygen, 2 moles of KClO3 will be used. It means to produce 0.3 mole of oxygen, KClO3 use will be 0.2 mole. So KClO3 used in reaction 1, that will be 2 divided by 3 into 0.3. We can directly write that this will be 0.3 mole. Sorry, 0.2 mole. 0.2 mole. This is wrong. This is 0.32 mole. So out of 0.32 mole, 0.2 mole of KClO3 is used in reaction 1. It means KClO3 used in reaction 2 will be 0.32 minus 0.2, that will be 0.12 mole. Now look at equation 2. 4 moles of KClO3 gives 3 moles of KClO4. So 0.12 will give how much? So I'm directly writing now. KClO4 formed in reaction 2. 4 moles gives 3 moles. 1 gives 3 divided by 4 moles. And 0.12 gives how much? This will be 0.09 mole. So KClO4 produced will be 0.09 mole, and we are given the molecular weight, multiply, you'll get the answer. So weight of KClO4 will be 0.09 mole into molecular weight is 138.5. So many grams will be produced. That is the answer. Third numerical. I'll write the equation again. MbR2 plus 2AgNO3 gives 2 AgBr plus MnO3 twice. We are given 30 grams of a metal iodide MbR2. Metal, it should be metal bromide. MbR2 gave 56.4 grams of AgBr on reaction with excess of AgNO3 solution. Calculate atomic weight of the metal. Atomic weights of silver and bromine are given. Let us say atomic weight of the metal is X, which we want to calculate. It means molecular weight will be X plus 160 is the molecular weight. Right? Now, starting moles will be 30 divided by molecular weight. So many moles we started with. And this AgBr will be 2 into molecular weight, and molecular weight will be 108 plus 80. This is 188 into 2. 376. So there's no need to even calculate number of moles. We can directly start use grams. See, X plus 160 grams gives 376 grams AgBr. Therefore, we have 30 grams of it. 30 grams will give how much? This will be 376 into 30 divided by X plus 160. So many grams of AgBr should be produced, and we are given the value of this weight. This is equal to 56.4, that is given in the numerical. It means 376 into 30 divided by X plus 160 is equal to how much given? 56.4. Calculate the value of X, that will be your answer. Next numerical. 2 NaCl plus sulfuric acid gives sodium sulfate plus 2 HCl. Second equation, 2 NaPr plus sulfuric acid gives sodium sulfate plus 2 HBr. Numerical is when a mixture of sodium chloride and sodium bromide was heated with sulfuric acid, amount of sodium sulfate formed was equal to the amount of mixture started with. Calculate percentage of NaCl in the mixture. Let us see, this is 10 grams mixture. It means total weight of sodium sulfate formed that will also be equal to 10 grams. If you start with 100 grams, this will be 100 grams, right? Now, molecular weights are given 58.5 according to equation into 2. This will be 103, and according to the equation, this will be into 2. Now, Na2SO4 formed in reaction 1. Let us say this is reaction 1, this is reaction 2. This is 2 into 58.5. That is 117. 117 gives 142. That is the molecular weight. 1 gives divided by 117. And if this is X grams, X will give how much? So much. Now, if this is X grams, naturally this will be 10 minus X grams. So sodium sulfate produced in reaction 2. This is 2 into 103. 206 gives 142. 1 gives 142 divided by 206. And 10 minus X will give how much? This plus this will be equal to 10. Same method as we did earlier today in one of the numericals. So this plus this is equal to 10. After that, calculate the value of X. I'm telling you the value of X. X will come out to 5.926 gram. It means out of 10 grams mixture, 5.926 grams is sodium chloride. From this, we can calculate the percentage of sodium chloride in the mixture, and that percentage will be 5.926 divided by 10 into 100. This is the percentage of sodium chloride in the mixture. Next, and the last numerical. A mixture of 8 grams of hydrogen and 52 grams of oxygen was burnt in to produce water. Calculate masses of reactant left and water produced. This is the numerical based on limiting reagent. I'm writing the equation. 2H2 plus O2 gives 2 water. Starting moles. 8 grams of oxygen will be 8 divided by 2, 4 moles. 52 grams of oxygen, 52 divided by molecular weight, this will be 1.625 moles. These are starting moles. Now we have to decide limiting reagent. If you remember, I told you number of moles divided by stoichiometry. This divided by 2 will be 2. This divided by 1 will be 1.625. So after dividing with stoichiometry, the lower number will give you limiting reagent. So this is the limiting reagent. And you know, limiting reagent will be completely consumed during the reaction. So number of moles after reaction. This will be totally consumed according to the equation. For 1 mole, 2 moles will be used. For 1.625, double of 1.625 moles will be consumed. So how much will be left? 4 minus 2 into 1.625. 0.75 mole of hydrogen will be left. Now coming to water, 1 mole will produce 2 moles. 1.625 mole will produce double of that. It means 2 into 1.625 moles will be produced. Oxygen left will be 0.75 into 32 grams. This is one answer. This one, water formed will be 2 into 1.625 into molecular weight of water, that is 18. This is the mass of water produced. Now coming to theoretical questions. Define theoretical yield, actual yield, and percentage yield. Theoretical yield is the one which is expected on the basis of balanced chemical equation. Actual yield is the experimentally obtained yield during the reaction. And percentage yield is actual yield divided by theoretical yield into 100. Right? There's something like this. If you appear in a test with a maximum marks of 40, and if you score 30, then actual yield is 30, expected by anyone, including parents, is full marks, that is 40. But what is the actual yield? Actual yield will be, percentage yield will be 30 divided by total, that is 40, into 100. That's how we calculate percentage yield. Second question. Out of 1 gram of O2 and 1 gram of O3, which contains more number of oxygen atoms? See, both will contain same number of oxygen atoms, but they will contain different number of molecules, right? Number of molecules of ozone will be less than the number of molecules of O2, but as far as number of atoms is concerned, number of atoms in both will be same, right?